Okay, let's just quickly look at the graphs that I gave you there. I said the effect of Q on the graph. If Q is greater than 0, you know where Q is now, né? That's the Y value of the turning point. If it's greater than 0 means positive, then it's going to be at the top of the origin. If it is smaller than, if it's equal to 0, it's going to be on the origin. And if it's smaller than 0, it's going to be below the origin. And then the second column, for the first column, it's just when A is negative. In other words, it's a sad graph. The next column is when A is positive, it's a happy graph. And Q is positive, then it's going to be happy and at the top. If it's happy and equal to 0, it's going to be happy and on the origin. If it is A greater than 0 and Q smaller than 0, it's happy, but it's cutting the x-axis. It's got intercepts. Okay, does that make sense? Everyone? Right. The effect of P on the graph. Now, we said yesterday, Q is always the vertical translation, where P is the horizontal translation with all the graphs. Parabola, hyperbola, exponential, all of them. So, let's look at it. The first one, when A is smaller than 0 and P is greater than 0. We also said that that one is confusing. If Q is positive, greater than 0, it's going to move to the left. When P is negative, it's going to move to the right. Look at those, compare them. P is positive, greater than 0, it's moving to the left with all of them. If P is negative, smaller than 0, it's going to move to the right. But I showed you why yesterday, ne? I said it's because X plus P is in a bracket together. So if I let that be equal to 0, I want to get P alone. It's going to be X equal to negative P. And for that reason, we always use it in the opposite way than we would something else. Q is already on the one side and Y is on the other side. Q and Y goes together. P and X go together. Okay. Happy? Alright. Let's quickly answer those questions at the bottom. What does A do? What does the A do to the graph? Very good, thank you. Happy or sad? If A is positive, it's happy. And if A is negative, it's sad. If you were thinking maybe it influences how big or small the arms would be open, you'd be correct. But remember, that's not really something that helps us to draw it. Or if I give you a graph and you see, oh, the arms are 5 centimeters away from each other, that means nothing to us. But the big role that it plays is whether it's positive or whether it's negative. Okay, what does Q do? Huh? It moves it up and down. No, there's not an asymptote. It's a parabola. Moves the graph up or down. And we can just write next to it, just to know, it's the Y value of the turning point. What does P do? That's I. Moves the graph left or right. And negative P is the X value of the turning point. Grade 11s, do you agree with me that we need to understand mathematics? No. No. In order for us to do it. That is this much true. This much. If you don't learn what it says here on this page, you can try to understand it as much as you like, you are not going to get it. You need to learn these things. This is the theory. Okay. Hyperbola. Standard form. G of x equal to a over x plus b plus q. The y-intercept, you let x be equal to 0. For the x-intercept, you let y be equal to 0. Asymptotes, we said it yesterday as well. It has two asymptotes, Panele, hyperbola. Parabola 0, hyperbola 2, exponential 1. Okay. The first asymptote, the horizontal asymptote. Don't get confused. It's a horizontal line, but it moves up and down. Therefore, its equation will be y equal to whatever value q is. Remember, I think you did it in grade 10 analytical as well, where you had straight lines or vertical and horizontal lines. And I remember when I was at school, it's confusing because when it's horizontal, you think of x. And when it's vertical, you think of y. Now, the way we always said we should remember it is when you've got a line, which axis does it cut? So if this is my line horizontal, which axis does it go through? The y-axis. No, it cuts the y-axis. So the one that it cuts is the one that it belongs to. So it cuts the y-axis, it's y equal to whatever the number is. If it's like this, which axis does it cut? X, so it's going to be x equal to whatever. Okay, so a horizontal line is y equal. Vertical line, x equal. Okay. Asymptotes, y equal to q for the horizontal one. Vertical, x equal to negative p. Once again, negative p. You can use a table with your own chosen values to assist you in drawing the graph. So if you feel like you're struggling to draw the graph, you don't know exactly where it's going to go, you are allowed to just substitute a value of your choice and plot the points. You remember like you did in grade 10. Draw it. You don't even have to draw it, you can just substitute it. But I will show you when we get to it, it's not even going to be necessary. Axis of symmetry. Do you know what the axis of symmetry is? If you look at the hyperbola, the place where you can draw a line and you fold it, and the left and the right side, or the top and the bottom, will fit exactly on each other. That's your axis of symmetry. So if you look in a mirror, the axis of symmetry is the mirror. Everything on that side of the mirror is exactly a reflection of what's on this side of the mirror. Right. If I put my hands like this, where's the axis of symmetry? Right there between my thumbs, because when I fold it there, the left and right fits on each other perfectly. Okay. So if you think about a hyperbola, you can even look at these examples here. I hope that you realize there are two axes of symmetry. You can cut it like this, and then the top and the bottom will fit on each other, or the left and the right, however you want to see it. But you can also cut it like that. Then they will also fit on each other. So there are two axes of symmetry. Now we are going to get into it more, but you can just look at it there, the axis of symmetry. They ask often in their questions, give the equation of the axis of symmetry. So the one is x plus p plus q, and the other one is y equal to negative x plus p plus q. Now let me just explain to you where it comes from. So the standard form is y equal to a over x plus p plus q. So the first axis of symmetry is everything just without the numerator. It's x plus p plus q. Okay, so if that was 5 and that is 2, then you'd say x plus 5 plus 2. So it will be x plus 7. Okay? Does that make sense? You just write it down without a. You do nothing with it. Just write it down without a. Now that would be the positive straight line. You agree a positive straight line goes in that direction, eh? And a negative straight line goes in this direction. So to get the negative one, you're going to do the same. Remember, the positive one we just said is x plus p plus q. That's a 1. And then the negative one is just going to be the same, x plus p plus q. But in front of these two, you put a negative. Just x and p. Not in front of q. Just p and q. So we said that if that is 5 and that is 3, then it would be negative x minus 5 plus 3. So it would be negative x minus 2. That's how we'd simplify. Okay, we're going to get to it. We're going to practice it. Don't worry. Just going through it with you. You can take a look there. The effects of Q, it moves it up and down. You can see that asymptote went up when Q is greater than 0. It goes up. And then when Q is 0, when there's no Q value, it's just on the axis. And when Q is negative, it moves the graph down. Something very important that I wanted to look at here with these two columns. If A is positive, let's just look at the right-hand side one. If A is positive, then your hyperbola is in the first and the third quadrant. If your hyperbola is negative, your A is negative, then it would be in the second and the fourth quadrant. You also did that in grade 10. I just want to remind you of it. Okay. But that's what the A positive and negative does. Boy Pedro, do you understand? Feeling unsure? You're fine. Okay. So here what does P do? It moves it left and right. So if P is positive, which side do you think it's going to move? Left. No. So P is a positive value, it moves it left, left, left. If P is a negative value, it moves it right, right, right. A positive A, first and third, first and third, first and third, first and third. A negative A, second and fourth, second and fourth, second and fourth, second and fourth. A positive Q moves up, a negative Q moves down. Can you see it's all the same, eh? It's repeating all the time, all the time, all the time. With some graphs, the variable just has a more specific value job as well. But the basics stay the same. Alright, exponential function. Very short. Standard form, AB to the power of x plus p plus q. Y-intercept, let x be equal to 0. X-intercept, let y be equal to 0. Right, asymptote, that's why it has an asymptote. B cannot be, or that b to the power of x plus p cannot be equal to 0. Okay, it can't be equal to 0, then it wouldn't exist. So q is the asymptote. Q is the asymptote. So it's the same as the hyperbola, it only just has one asymptote. With the hyperbola, it was also y equal to q. It just had another one, x equal to negative p as well. This one is the same, y equal to q. Right. Now, in order for us to understand the exponential function, we already took a look at it yesterday. But let's just do this page, then I would be more comfortable about you guys understanding all of it. The effect of A and B. So just to understand the difference between the A and the B. I told you yesterday, A determines whether it's positive or negative. So whether it's at the top or at the bottom. B determines whether it's increasing or decreasing. Do you remember? If we look at the positive, the ones at the top, I said if B is a fraction, it's going to start at the top and decrease. If B is a number greater than 1, it's going to start at the bottom and increase. When A is negative, it would be a reflection of these two. So if A is negative, it's at the bottom, and B is a whole number greater than 1, it's going to start at the top and decrease. If B is a fraction, it's going to be a reflection of that one at the top, it's going to be at the bottom and it increases. Okay, so that's what we want to check out here. So I'm going to work on my calculator. You can also use your calculator just to check the answers. And get your pencil ready. We'll draw these graphs. Once we draw it, we see it, we understand it. Okay, first one we have is 2 to the power of x minus 1 plus 2. You remember why the base can't be 1, eh? Because 1 to the power of anything is 1. I just have a straight line. So that can't exist. Okay, so the smallest one we have is 2 to the power of x minus 1 plus 2. Right, what is the value of A? No, 2 is the base. What's the value of A? 1. Do you understand? Sure. Alright, if I wanted to find the y-intercept, you remember how we find the y-intercept? You let x be equal to 0. So you can type that into your calculator. I will do it here as well. I've got 2 to the power of bracket 0 minus 1, close the bracket, plus 2. It gives me an answer of 2.5. So it will be 2.5 or 0 and 2.5. Alright, do you remember what we said? This is Q, ne? This plus 2. What did we say is Q? Look at the previous page at exponential. What does Q do? It moves it up and down, so it's the asymptote, ne? It's the asymptote. So the asymptote is y equal to Q, and Q is 2. Y equal to 2. Do you know how we draw in an asymptote? With a dotted line. Do you know what the asymptote is? Your graph is not allowed to touch it. Yes, it's like a limit. It goes nearer to it, but it never touches it. Okay, so first off, we always draw the asymptote first. It's the easiest one because we read it from the equation. Now we've got a y-intercept at 2.5. Is there going to be an x-intercept? No, there can't be an x-intercept because there's an asymptote. Ne? Right, now because A is positive, I know my graph is going to be at the top. Ne? And B is not a fraction. It's a value greater than 1. Can you remember what that graph looks like? It's increasing. It's going to increase. So, because there are no other, we call it critical points. We can just draw the graph because you're not going to get marks for anything else. You get marks for the asymptote, you get marks for intercept, and you get marks for the shape. So knowing it's going to increase. Whether that one is supposed to be a millimeter to the top, you're not going to lose or gain marks for that. Was it difficult? You just drew your first exponential function. Easy peasy. Next one. 3 times 2 to the power of x minus 1 plus 2. What's the value of A? 3. Okay, now we also need to get the x of the y-intercept. So I'm going to put a 3 here in the front. 3 times. And it gives me an answer of 3.5. What is the asymptote? Thank you. Don't ever say 2, just y equals to 2. There. So I draw in my asymptote. My intercept will be at 3.5. What is the value of B? What's B? 2. So what will the shape look like? Once again, the same. Increasing. So it looks almost the same, except it's moved up a bit. Next one. A half times 2 to the power of x minus 1. Right, what's the value of A? A half. The x-intercept. Yo. If I substitute it in there, I say a half times it, it's 2,25. 2,25. What's the asymptote? Dankie Banele, y equals to 2. I draw the asymptote in first. My intercept is going to be closer to the asymptote now, ne? It's 2,25, it's close. And what will this graph look like? The same. I'm so glad you didn't say it's going to decrease. Ne? It's when B is a half that it would decrease. But B is still 2. Can you see that? You understand that? So all that value of A does is it increases and decreases the slope. This one where A was bigger, it goes up quicker. Where A is a fraction, it's going slow. Okay. Right, let's see what happens here. Who can tell me what they think will happen here? 0 times 2 to the power of x minus 1 plus 2. But what's the graph going to look like? Okay, let's see. A is 0. Y-intercept? Let me see. 2. Asymptote? Now, just for safety, I'm going to choose a value to substitute in, okay? Just to see. So, in the place of x, I'm going to put in -5. I just want to see what the value is going to be at -5. So, I put in -5, and my answer is 2. And then I put in a +5, oops, and my answer is 2 as well. If I put in 10, the answer is 2 as well. If I put in -10, the answer is 2 as well. Why is that happening? Anything times by 0 is 0. So because A is 0, it cancels that whole thing out. So can you see A can't be 0 either? Nee? B can't be 1, A can't be 0. So this graph would just be a straight line on y equal to 2. Right, second last one. -3 times 2 to the power of x minus 1 plus 2. What's A? Is there someone who can guess, who can anticipate what this graph is going to be different like? It's going to be at the bottom. Okay, it's going to be at the bottom of the asymptote. Right. What is the x-intercept? Let's quickly substitute in there. I make my, the y-intercept, I make my x 0, put in -3. Like that, ne? It's a half. So that value is going to be 0 and a half. The asymptote? Y equals to 2. Okay, now let's just think for a second. Normally, this graph doesn't cut the x-axis, ne? But if you think about this, we said that this graph would be a reflection, basically, of that graph. It's going to be a reflection of this one, where A was 3. So we expect it to be reflected just below here, like this. Okay. But if I were to reflect it here, can you see it's going to cut the x-axis? Can you see it? Now whenever a graph cuts the x or the y axis, we have to write it down. We have to show it. Okay. So because I can see that it is definitely going to cut the x-axis, I'm going to calculate it. I'm going to say I let y be equal to 0. I'm going to take the 2 over, negative 2 equal to negative 3 times 2 to the power of x minus 1. Divide by negative 3, I've got negative 2 over 3 equal to 2 to the power of x minus 1. Oh, now in this case I can't calculate it any further. Oh, this is going to be positive, sorry. Because I can't do it without a calculator. But in an exam it would be possible for you to do it. Okay, it's just a stupid example here. So this one, I can't draw it, but I know it's going to go like this. I can't calculate the x-intercept. And there the graph is. It's just been reflected. Okay, and then the final one. Y equal to a half to the power of x minus 1 plus 2. What's A? What's B? A half. Let's calculate the y-intercept. It's going to be a half to the power of 0 minus 1 plus 2. It gives me an answer of 4. What is my asymptote? I put in my asymptote. Intercept is at 4. What's this graph going to look like? Now it's going to start at the top. And it's going to go down. Okay, so I just want you to take one step back to this page where we wrote down. Okay? If it's a positive A and B is greater or equal to 1, the graph is going to look like this. Okay? Oh, can't you see? Positive A and B greater than 1. This is what it's going to look like. If it's a positive A and B is greater than 0 but smaller than 1, the graph is going... Oh, what am I doing now? Yeah, sorry. Askies. Okay, and then when A is going to be negative. When A is going to be negative, but B is still greater than or equal to 1, then it's the reflection. Here, when A is negative, B is greater than 0, smaller than 1, it's the reflection. Okay. I told you guys, we're going to jump into the deep end, ne? Right. So we've spent maybe one period on functions. We're going to start with exam papers now. Okay. Previous exam papers. You're going to have to keep those pages that we just went through now. You're going to have to keep it on hand when we do this. So I want you to start. You can write November 18. This is question 5. 5.1. They've given you two functions. F of x equal to 4 over x minus 3 plus 2. And they've given you g of x equal to x plus 2. Okay, I want to know first off, from anybody, dankie boy Pelu. F. What graph is it? Is it straight line, parabola, hyperbola, exponential? Hyperbola. How did you know it's a hyperbola, Vanilla? Vanilla. Hyperbola, Vanilla. You looked at the standard form, and what is the same in this one than in that standard form? What's the same in that standard form and in this F? It's the fact that x is a denominator. Okay. Don't just say when it's a fraction it's a hyperbola. There can be a fraction, but then x is the numerator. Then it's not a hyperbola. When you have a fraction and x is the denominator, then it's a hyperbola. Okay. And g, what is it? Is it a denominator? Does it have it to a power of 2 to make it quadratic? Is it the exponent to make it exponential? So what is it? Straight line. Okay, when you guys come to class tomorrow, we're going to start. I'm going to do that first one and the second one with you, and then you're going to start to do it by yourself. You must go and learn that summary. Okay, you must know it well.